the unit circle and large angles. For 0 degrees, the x coordinate is 1, the y coordinate for this point is 0, so we get these ratios. For 90 degrees, the x coordinate is now 0, the y coordinate is 1. When we substitute the values in, for tan 90, we have the y coordinate 1, x coordinate 0. When you divide by 0, you get an undefined value, and this is why you have an asymptote on the graph for tan at 90 degrees. Then for 180 degrees, 270 degrees. For minus 40 degrees, we have a positive x coordinate and a negative y coordinate for this point. We have the sine ratio, cosine ratio and tan ratio. So how do we generate minus 400 degrees? So starting from the positive x-axis, so the angle so far is 0 degrees, so that was minus 40, and if I keep going, that's minus 90, minus 180, minus 270, minus 360, and now the total angle I've gone through is now minus 400 degrees, and the x coordinate and the y coordinate at this point is exactly the same as here for what we had for minus 40 degrees. So these ratios and these ratios are identical. So we've seen that starting from the positive x-axis, going anti-clockwise gave positive angles. So that was 90, 180, 270, 360, 450 and so on. And again, starting from the positive x-axis, going clockwise gave negative angles. So we've got an angle of minus 90, minus 180, minus 270, minus 360, minus 450 and so on. And we can generate angles of any size, positive or negative. And using this method and the definition here for sine, cos and tan, we can generate graphs for large positive angles and negative angles for sine, cos and tan. In this demonstration I have my unit circle again, and I'm going to sketch out the cosine graph for angles between 0 and 360 degrees. So at the moment the angle is 0 degrees and the cosine of 0 is 1, and following the same method as before, the same definitions for large angles. So as I go round in an anti-clockwise manner, I can see that I've got acute angles between 0 and 90. So this portion of the graph you would get anyway with the right angle triangle method. But the new definitions that we've been through using the coordinates to work out the trig ratios, we can go beyond 90 degrees like we're doing here, and we're at 180, going past 180, heading towards 270, and we can see the graph being generated there until we get to 360 degrees. And we can do something similar for negative angles, we can do something similar for the graph for sine and tan. So if you're using a right angle triangle and these definitions for your sine, cos and tan ratios, then you're limited to angles which are acute. And if you're using a unit circle type method and using coordinates for a point which is on the circumference of the circle to work out your sine, cos and tan ratios, then you can have an angle of any size you like, whether it's positive or negative.